Hello, this is Geometry Notes 9.3 on rotations. We're going to start with a warm-up question. Go ahead and do it. After you are done, go ahead and unpause the video. So pause the video right now to do this problem. Okay, let's say that you didn't know how to do this, so you didn't even pause the video. We want to find the midpoint. Actually, we are given the midpoint of the segment AB, and we want to find B. So A, we are given, is 5, 3. The midpoint is 2, -1. I'll put that in green. So the midpoint is 2, -1. And we want to find the coordinate of B, which is the other end of this line segment. Well, by symmetry or by congruent triangles, we can talk about from 5 to 2, I am subtracting 3. So x coordinates have to go in the same direction. 2 minus 3 gives us -1. Y values from 3 to -1 is -4. -1 minus 4 is -5. That is our answer. That's all you have to do on a problem like this. If you are confused, then let's check your work by looking at this graph. So this is not required. This is just if you're confused as to what I did. So A is 1, 2, 3, 4, 5, up 1, 2, 3. We are given A. We are also given the midpoint, which is over 2 down 1. And the question asks us find the coordinate of the other endpoint of AB. And we found out that that was -1, 1, 2, 3, 4, 5 in the negative direction. So that is B. Now you can visualize and see that that does indeed work. For our x values, we subtracted 3 each time. And for our y values, we subtracted 4 each time. And you can easily see that those are congruent triangles, and it shows that M is indeed the midpoint of line segment AB. So this method is just perfectly fine. The check is fun to see that we approach that problem correctly. Now, that is just a warm-up, so let's get into rotations. So before we get into rotations, we want to review of transformations are reflections, translations, rotations, and dilations. I don't want you to memorize any rules. I want you to be able to understand the concept. So how do you remember rules? For instance, a reflection over the line y equals x. Let's just draw a graph and then draw just a quick sketch of a line y equals x. And I always pick a point that's over a lot, up a little. For instance, over 4, up 1. And if I fold my graph over the green line, that point, blue point, reflects up here. Over a little, up a lot. So we can see that the rule is I'm just switching my x's and y's. Again, don't memorize the rule. Let's try another rule. I want to find the rule for a reflection over the line y equals -x. So now I'm going to draw the line y equals -x, just a sketch. So y equals -x, and I'm going to find a point that's over a lot, up a little. How about just the point 4, 1? It's just a random point. And if I fold my graph over the green line, then my reflection of the blue would go down here into the red, which would be left a little, down a lot. So that rule we can see is I'm switching x's and y's, and I am taking the opposite of them. Okay, so that's just a review of reflections. Reflections are lowercase r. Now today is a new transformation called a rotation. A rotation is, the symbol for it is a capital R, and we're going to do the same idea. I don't want you to memorize anything. I just want you to understand concepts. So let's start with the point over a lot, up a little, like the point 4, 1. Again, that's just a random point. And I need you to know that any rotation is going to be in the positive direction, which is counterclockwise. So this is a rotation with respect to the origin of 90 degrees. That's what this means, a rotation with respect to the origin of 90 degrees. So I'm just eyeballing what 90 degrees looks like in the counterclockwise position. This would be 90 degrees. So it looks like I went over a little to the left, so -1, up a lot. So using those same two numbers, 1 and 4, I'm just seeing now it's -1, 4. So this rule I can see is my original point xy. The original x is now my new y, so that's x, and my original y I'm taking the opposite of for my new x position. Again, I'm not memorizing this rule, I'm just understanding how the picture looks. Let's try a rotation of 180 degrees in the same manner. So I'm going to draw an XY axis sketch. I'm going to choose a point over a lot, up a little, and again, I'm just going to stick with 4, 1 for no particular reason other than it's over a lot, up a little. And now with respect to the origin, we are going to draw in our what is 180 degrees looking like? It looks like maybe like this, right? 180 degrees, 180 degrees. And so that looks like this point is over a lot in the left direction, down a little. So the rule is going to be my new x was the opposite of it, and my new y is the opposite of what it was. So it's just the opposite of both. Again, I don't have to memorize that. So let's go on and just answer some questions that you would be asked on a homework assignment or a test or a standardized test. Let's look at number 1. First question says, find the coordinates of a point P rotated 180 degrees around a given center point C. So P is my original point, 5, 3, and it's going to be rotated around a point, I'll just call it C with a green, so 2, -1. Let's just, you know what? If you've never seen a problem like this before, let's draw a picture. Let's figure this out. Over 1, 2, 3, 4, 5, up 1, 2, 3. Now that's P, and that is going to be rotated about this point to -1, just this like random point. So what does that mean? Well, let's kind of figure this out. It's almost like we have a new set of axes, and we're going to rotate that point P, where is it? We want red. We want to rotate that like 180 degrees, and I'm not really sure what's, so I'm a little confused. I'm actually not confused, but I'm sure you are. So at this point, I go to GeoGebra. Let's go to GeoGebra. So I'm going to pull up an applet that I created. And so for instance, for 1, if it's being rotated 180 degrees, would go up here. Like for instance, we were doing that before with respect to the origin. For 1 rotates 180 degrees to this -4, -1. But if I change this point of rotation, my new value, A prime, is no longer has those numbers like 4, 1. Like when we rotated with respect to the origin, our A prime was the same types of numbers, 4 and 1, but just, -4, -1. But when I move my center of rotation to another point, my A prime, my primes are going to be different. So it seems really complicated. However, if you keep moving stuff around, you might notice something. And do you guys notice that it's almost like let me just go to like a random point, okay? Just like here, I'll just go here. Let me just mark this up a little bit. So let's say I'm going to go left. Let's see, -1, 2, 3, 4, 5. And here, this is also, what, -5. And then if I go up, this is what, up 1, 2, 3, and this is up 3. And this looks familiar. This idea of, isn't that center of rotation actually the midpoint of a line segment A prime? So we don't have to use our rotation symbols. GeoGebra is amazing where we can figure out concepts that are quite challenging in a really quick manner. So if you didn't quite get that, I will explain it more clearly here. So what I want to let you guys know is that this question is just actually I'm just going to, so this question is just actually a midpoint formula problem. So C, my center of rotation, is the midpoint. And so from 5 to 2, I'm subtracting 3. So I'm going to subtract 3 here to get -1. 3 to -1, that's -4. -1 minus 4 is -5. This is our answer. Let's actually graph it over here. And I am going to, this is kind of confusing. So we're going to erase what I did here and say, you know what? It doesn't have to be confusing. We can do the same thing we did before, where P is 5, 3, C is over 2 down 1, and P prime, let's just see if this makes sense, is -1, -5, 1, 2, 3, 4, 5, and that's my P prime. If we connect those points, you can easily see that that is a 180-degree rotation with respect to our midpoint, or in other words, with respect to our center point, which is C. And to further understand this concept, do you see that our x values, to get from P to C, we went -3, and from C to P prime, we went -3. That was our x values. And to go from the y values, I'm going down. Let's see if this works. Down 4 and down 4. So it's really fun. It's just a midpoint problem. Hope you enjoyed that. That's actually thanks to GeoGebra for helping us understand it conceptually before we had to do anything difficult. This is not a difficult problem. In fact, do you guys see it's the exact same problem that we had in the warm-up? The exact same answer. It is just worded differently. It's the same concept, whether it's a midpoint of a segment or if it's a center of rotation of a segment of 180-degree rotation, which is really fun. I think it's really fun, and GeoGebra really helps make it make more sense. So let's go ahead and do number 2. And we'll take it like we really understand the concept. Find the coordinates of a point P rotated 180 degrees around a given center point C. We can recognize this is just a midpoint problem where I have my original endpoint, which is P. I have my center of rotation, which we can understand conceptually is our midpoint, 1, 2, and we just need to find out what the other endpoint is, which is also called our image. So P is our pre-image, P prime is our image. To go from P x value to C's x value, we are adding 4. So I have to add 4 for my x value here to get 5. From 4 to 2, I am subtracting 2. 2 minus 2 will give me 0. This is our answer. That's all you would have to do. Now I want to make sure you really understand this problem. So I am going to use our graph to check our answer. That is not necessary on homework or a test, but just for our purposes for notes, I think it's really helpful to see what you've done. -3 up 1, 2, 3, 4. That is our P value. Our C is our center of rotation, or in other words, it is just our midpoint. And then we found out that our final answer is over 1, 2, 3, 4, 5, up nothing. And you can easily see Not only is this a rotation problem, it is also a midpoint problem. And again, you can see that clearly by going from our P value, we went to the right by 4, and from C in the X direction, we went to the right by 4, and then in the Y direction, we went down by 2, and we went down by 2. So it's just a congruent triangle problem. It is also a midpoint problem, and it is also a rotation problem. So just a delightful problem, reviewing lots of topics throughout the year. And again, the GeoGebra really helped us understand the concept of this without making this be something where you have to memorize. You don't have to memorize anything. So we're done with rotating 180 degrees around any given point. Let's try another rotation concept, and that's problem number 3, 4, and 5. This next rotation problem says find the coordinates of a point rotated 90 degrees around the origin. So I don't memorize anything, I just think about the idea. So let's start off with figuring out what the rule is for a rotation about the origin. So I'm going to start off with over a lot, up a little. So just a random point, let's call it 4, 1. We are going to now rotate it with respect to the origin and come up here. And that would be what? Negative a little, up a lot. So our rotation of 90 degrees with respect to the origin, the mapping notation is xy gets mapped to the opposite of y comma x. Now, you can say, what am I doing with that? All you have to do here is to say if my original point is 1 comma 4, then my p prime is going to be, because we're just rotating about the origin, is going to be the same rule over here. So we're looking at my new x value was the opposite of my original y, and my new y value is my original x. That's my answer, but of course we want to look at the picture and does this make sense? So my original value was over 1 up 4, that was p, and p prime we found out was negative 4, 1, 2, 3, 4 up 1, and let's just verify that that makes sense. So from p to the origin, and then from the origin to p prime, it sure looks like 90 degrees, but can we actually verify that? We certainly can. Do you understand that the slope from the origin to P is up 4 over 1? So that slope is 4. The slope of our point P prime to the origin is down 1 over 4. And again, this is review from what we've done earlier in first semester. Perpendicular lines have opposite reciprocal slopes. So again, this is a verification that this is indeed a 90-degree angle. Also, you can multiply those two slopes and you get -1, another verification that the slopes are at right angles. Let's look at a GeoGebra example so that we can understand this concept even a little better. And so here, if I'm taking 4, 1, and I'm rotating it 90 degrees with respect to the origin, you can see it goes to -1, 4. Our problem that we just did started off with 1 comma 4. And we can see here that a prime is indeed -4 comma 1. So it's kind of fun just using this dynamic software. You know, this is just any random triangle. Just play around and see where items go. And we can use our rule from where x, y gets mapped to with a 90-degree angle. But again, this GeoGebra software really helps us to identify our answer. So like number 4, the question is, what is the new coordinate of point P when it's rotated 90 degrees around the origin, and P's original coordinate point was negative 5, 3. So let's go to negative 5, negative 5, comma 3, negative 5, comma 3. And if that's kind of confusing, we can move these other coordinates so it's not as obnoxious here. And we see that I'm going to have to shrink this a little bit and move this. Again, fun dynamic software here. Let's move B off a little bit. But anyways, our answer is negative 3, negative 5. But let's go ahead and do that by hand because on a test you wouldn't necessarily have this dynamic software. And GeoGebra is free. I would highly encourage you guys to go to geogebra.org and to do some playing around like I did here. Number 4. So we already know the answer because of GeoGebra, but let's go ahead and do this problem. So we're going to now, having some technical difficulties, let's pause. Okay, back to number 4, we have our original point, negative 5, comma 3, and we want to figure out what P prime is going to be, and we'll just figure out what that rule is for a mapping of a point with respect to the origin 90 degrees around it. So to do that, easiest thing to do, pick a point over a lot up a little, like 4, comma 1, and draw as best as you can a right angle with respect to the origin again. We're going in the counterclockwise direction for a positive 90 degrees. So that would go up here, just kind of eyeballing it, so negative a little, up a lot. And so our rule would be for a rotation of 90 degrees with respect to the origin is a coordinate point x, y gets mapped to negative y, comma x by just looking at those values. So now I know I'm going to take the opposite of my original y, comma, the x value. So that is my answer. We are done with that problem, but of course I like to show why graphically. Again, this is not necessary, but for our notes, it's really helpful. Negative 1, 2, 3, 4, 5, up 1, 2, 3. That is P. We figured out that P prime was negative 3, 1, 2, 3, down 1, 2, 3, 4, 5. On a test or standardized test, you aren't always given a grid, and that's why I'm doing this just as a check, something that I don't want you to rely on in case you are not given a grid. This definitely looks like a right angle. Let's verify it by looking at slopes. So the slope of our original segment from P to the origin is down 3 over 1, 2, 3, 4, 5. So that original slope is negative 3/5. And the new slope, meaning from P prime to the origin, is up 5. So this is now the opposite reciprocal, up 5 over 3. Those are opposite reciprocal slopes. They multiply to get negative 1. Therefore, we know that is indeed a 90-degree angle. We only have to do one more problem. Hopefully you understand these two concepts really well now by looking at the graphs. So let's start off with our original point. I'm going to write it in blue if I can get there. So we have P is 2, negative 5, and P prime is, let's see, and that should all be in red. So again, I am rotating 90 degrees about the origin, and I am going to make sure that I don't memorize the formula. And so I'm just looking at a coordinate point like over a lot, up a little, like 4, 1. With respect to the origin, we're going to do a rotation, and that looks like that would be about a little to the left, up a lot. So that rotation of 90-degree mapping notation, x, y, gets mapped to negative y, comma, x. So I'm going to use that here. I'm going to take the opposite of the y value, comma, the original x value. That's it. That's our answer. We're done. But I am not going to finish right now because I want to show you, verify that we indeed did this. Over 2, down 1, 2, 3, 4, 5. That is P. And then P prime, we got to be over 5, 1, 2, 3, 4, 5, up 2. With respect to the origin, let's look at both slopes. So our original slope from the origin to P, we went down 1, 2, 3, 4, 5 over 2. So that slope is negative 5. Oh, that should be green. So negative 5 over 2. And this slope is up 2 over 5. So that is the opposite reciprocal slope. So we have indeed figured out that that is a 90-degree rotation. This is fun. Hope you guys have had a lot of good learning. It's been really a good review of a lot of concepts. Have fun. If you're confused at all, email me. Have a great day. And again, play around with GeoGebra. I'll send you my link to those applets. It just makes things so much more understandable and enjoyable. So have fun with your math. Bye-bye.